All right, so it's recording now. Talia, how are you? I know that's Talia. I know Talia's last name is Marsden. How are you, Talia? You okay? So Talia, today's a more active class. We're trying number 1, all right? With the information that's there. If you need any help, just let me know, all right? But try number 1, okay, Talia? Find the gradient, find the midpoint, and the equation of the line. So these are the formulas over here. Just in case you need to remember, all right? And Rosalie, you're trying number 1 as well. Cool, when everybody else come, they try number 2. All right. And Rosalie, you said you were having some issues with this. So if you need any help at all with how to find the gradient and the midpoint and the equation of the line, just ask me. I'm here to help. All right. I just want this class to be a little more active. You understand what I'm saying, Rosalie? So we're doing some practice today. We're doing some practice with this. I know we just learned this last class, but we just need a little practice. We need a little practice with it. Okay, guys. I'm not seeing Denise, which is a little strange. Denise is usually here all the time. Shireen is here, Talia is here. Looking for the other students. Oh, okay, so Jay is here now. And Anisha is here now, okay. Denise. All right. Hey Jay, hey Anisha. I'm so happy to see you guys. So happy. How are you guys? So Jay and Anisha, we're doing a more active class today. So today, I want you guys to work on number 2. Shireen, Talia, and Rosalie are working on number 1. So remember last class, guys, we did the gradient, the midpoint, and the equation of the line. So today, we doing some practice for it. Cool. So we're having a more active class today. So I want you guys to try number 2. Jay and Anisha, number 2 is for you. And Shireen, Talia, and Rosalie, number 1 is for you guys. Let's try it out. All right. Just take your time. All right. If you need any help, let me know. I'm here to help as well. But today is just a little more active. We want to do a little practice for what we learned last class. And of course, guys, we're gonna go through both of these questions. All right, we're gonna go through them. Okay, so Denise is here now. Good, guys, good, good, good. So Denise is usually in the group with you guys. Denise, how are you? Hey, Denise. I hope you can hear me. Are you with me? You with me, Denise? How are you? All right, so Denise, we're doing some practice from what we did last class. Remember, we learned last class about the gradient, the midpoint, and the equation of the line. So you'll be doing number 2 with Jay and Anicia. I want you to find the gradient, the midpoint, and the equation of the line with the points, with the information you have there. If you need any help, just let me know. I'm here to help, all right? And just take your time. Remember, the formulas are right over here in case you need them. And just let me know. Just let me know. I'll be here to help you right through. All right.
Okay, sir.
So we're doing some practice, okay? All right, let me check with Shireen. Shireen, how are you feeling about this now? Need any help? Shireen? Not seeing Shireen. Talia, how you feel? You worked it out? Talia, are you with me? Not hearing anything from you, Talia. Yes, sir. All right, so you found the gradient and the midpoint. Okay, so the midpoint. Trying to find the y-intercept now. All right, well done, Talia. Oh no, this is J. Okay, so J. Hmm. Hey J, So Jay, for the midpoint you just sent, check the second point. All right, Jay, check the second point. The first one, the 1 is right, but the -4, check that for me. Check the -4 one more time. All right, Talia, so your gradient is right, Talia. Your midpoint is right, Talia. Hey guys, don't be afraid to open up to say I need a little help here or there. Remember, I'm here to help you. Remember, I'm your teacher. Here to make you stronger, here to help you as much as I can. You can always reach out if you're having any issues or if there's nothing you don't understand. Don't feel any way to ask me, you know? And we're gonna go over them together as well. All right, so Denise, that's right as well. Well, Denise, for your gradient, I think it should be a -2. Yeah, you fixed it. All right, cool. So Anicia, 0 is the first point, but I think the second point is 2.5. Is it? No, man, it's 0.5. You're right. You're right.
Sir, what you said, it's wrong?
No, it's right. 3 plus minus 2 would be 1 over 5 over 2. So it would be 0.5. So Denise and J. Well, no, J is still working out. Denise, your midpoint for the second point, you should add 3 to -2 and then divide that by 2. So that should be 1/2. So I think the midpoint is 0 and 0.5. Like what Anicia said. Your gradient is right though, Denise, but your second point for the midpoint. You can check that. We're gonna do it together, guys. We're gonna do it together. Rosalie, how you feeling about this? Shireen? Trying to check with you guys. Check with Talia. Talia got 2.5 as well. Why are you guys getting 2.5 here? I'm trying to wonder why.
Because we're using a +2.
Yeah, why are you guys using a +2? It's a -2 here. This is a -2, guys. It's -2. Let me make it red. It's -2.
It's 1.
If you add them together, you just should get +1. Yeah, you shouldn't get a 2.5, guys. You should get 0.5.
No, I'm saying initially I didn't see that the 2 was a negative.
Oh, maybe it's not bold enough. It's -2, guys. It's a -2, guys. This is -2. Shireen, Rosalie, I noticed you guys are really silent. I know you guys probably at work, but I just want to check with you guys. How you feeling? Remember, if you have any issues, just let me know. It's really not so bad. All right. And I'm going to help you guys out now. All right. So I think I'm going to start with Jay, Anicia, and Denise, and then I'm going to do Rosalie, Talia, and Shireen. So I'm going to start with you guys on the bottom first. I'm going to start with number 2. Jay, how are you? How are you looking for you? Tell me something in the chat, at least. Hello, Jay, are you okay? Not seeing anything from Jay. Talia, I think you may be right. Yeah, Talia is right. I think your y-intercept is right to Talia, so I think you're okay. But let me just do Jay, Anicia, and Denise's question first. All right, guys. So Jay, you ready? Let me just check with you. If you don't finish, it's okay. We're gonna do it together now. Denise, you looking as well? Hey guys, come on. I feel like I'm talking to myself. Everybody all right? Can you guys hear me? Hey guys. Anicia, are you there as well?
Yes, I'm here with you. My daughter is just giving me a letter, so that's why I don't open my mic.
Yeah, I figure maybe it's the same thing for Denise as well.
I'm here, sir. Sorry about that.
All right, Jay, how about you? Last call, Jay. Give me a thumbs up. All right, good. Okay, guys, so we're going to do yours first. We're gonna do number 2. And let's do it together, guys. So the first thing we need to find is the gradient. And the gradient is equal to y2 minus y1 over x2 minus x1. Remember, guys, the first point, that's what I tend to use as A. So the first point I usually use for x1 and y1. And the second point I use as x2 and y2. Cool, I always do that. I suggest you guys always do that as well. So this is x1, this is y1, this is x2, and this is y2. So easy, we just have to say 3 minus 2, right? So y1 is -2, so this is 3 minus -2 over x to the 2 is -1, and then 3 is x to the 1 is 3. So am I doing this right? Let me just double check. Yeah, I'm -1 -3. Does that make sense? So y2 is 3, y1 is -2, and x2 is -1, and x1 is 3. So I'm actually going to end up with 3 plus 2 here, because the two negatives here will give me a plus, over -1 -3. So I end up with 5 over 4. So did I do something wrong here? I really hope I didn't, because I'm thinking that you guys' answers are kind of different.
No, sir, I did number. I'm just realizing I answered number 1.
Oh,
Sherry, yeah,
it's the
Rosa.
same. Yeah, I think Denise may have done number 1. Still getting 2.5 answer. All right, so all right, so let me check with Anicia and Jay. So you guys are doing the second one, guys. Anicia, Jay, and Denise. You guys are doing number 2. Am I right? So that's who we're checking with right now. Jay, Denise, and Anicia. So, but Denise, you said you did number 1 instead. You didn't do number 2. You did number 1. All right.
No, it was a mistake, sorry.
All right, it's no problem. So I'm just gonna put you up here then. So Jay and Anicia, this is what you should have gotten: 5 over 4 as your gradient, which is 1.2. When you divide 5 by 4, guys, you're gonna end up with 1.2. So 1.2 is your gradient. Let's find the midpoint now. Let's find the midpoint. Cool. Let's find the midpoint, guys. So the midpoint, guys, is kind of easy to find. Let's call it capital M, big M, not small m like the gradient, but big M. And it's x1 plus x2. The first value is x1 plus x2, which in this case is 3 plus -1. So 3 minus 1, guys, is just gonna give us 3 minus 1. 3 plus a -1 is just gonna be 3 minus 1. So 3 minus 1 over 2. And then the second value is y1 plus y2 over 2, which is -2 plus 3 over 2. And of course, when we add -2 to 3, we're going to get a +1. So we actually should get, let me just clear this for a moment. We should end up with 3 minus 1 is 2. So you're going to end up with 2 over 2. And the other point is going to be 1 over 2. So that's actually going to be 1 and 0.5. So this is what you should get as your, this is exactly what you should get as your midpoint, 1 and 0.5. So I don't know where you guys got mixed up. Maybe you guys were doing the first question too. Anicia, you were doing the second question or the first one?
No, you know, the first question, I did my second question, but the thing is I put 0 and 0.5, which it should have been 1 and.
Yeah, how did you get the 0? The only way I've seen the 0 is if you add the first question has 1 and -1. So this should be 0 for this first one. So I feel like everybody was just doing the first question, you know?
The first question I want to get it because when I was going over mine, I found out that I put a 3 instead of a 2. When it should be 3 minus -2, I put 3 minus -3. I guess I'm not so good.
Oh, sorry guys, I'm so sorry. Yeah. All right, so the midpoint here, guys, is supposed to be 1, 0.5. Cool. And then for the equation of the line now, guys, it's not too bad because now we have the gradient, guys. We have the gradient as 1.2. So remember, guys, the general equation for the equation of the line is y is equal to mx plus c. Cool. So we can say y is equal to m, which is 1.2 x plus c, right? And we need to find c. How do we find c, guys? We can use any point on the line and put inside it to find c. Cool. So what point am I gonna use? I can use a midpoint still, you know, but I can also use the 3 and the -2. Let's use the first point, the 3 and the -2. Cool. Because one thing's for sure, this point is always going to be right. So let's use the first point, the 3 and the -2. So where you see 3, I'm going to put, where I see x, I'm going to put 3 there. And where I see -2, I'm going to put this for the y. Cool. So I'm going to end up with -2 is equal to 1.2 times 3, right? Anywhere I see x, I put 3. And anywhere I see y, I'm going to put -2 plus c. So I'm going to end up with -2 is equal to 1.2 times 3 is actually 3.6, guys, plus c. And then I'm going to put the 3.6 over to the left side. So I'm going to get c is equal to -2 minus 3.6. So my c here should actually be 5.6. So that's my c. And the last thing for the equation would be y is equal to 1.2x plus, well, it's a negative actually. This is -5.6. -2 minus 3.6 is -5.6. So the c is actually -5.6. Cool. So that's the equation of the line, guys. I put the point inside this and then I get the value. All right. Man, it's kind of rough. Maybe we need to do one more. Maybe we need to do one more. But this should work it out, guys. This should definitely give you the values. So Jay and Anicia, not too bad. It was kind of rough. Maybe we can do another one, right? Right, guys?
Okay, let's try another one, sir.
Yes, so we're gonna do another one. But in the meantime, guys, let's do the next one. Let's do the one for Shireen, Talia, Rosalie. Let's do the next one, guys. So ready? We're doing the next one now. So Talia, Rosalie, Shireen, Denise. Let's do the first one now, right? So we're gonna do the same thing. M is equal to y2 minus y1 over x2 minus x1. This is x1, this is y1, this is x2, this is y2. Cool. So y2 minus y1 would be 3 minus 2 over x2 minus x1, which would be -1 minus 1. So this is actually going to give us 1 over -2, which is the same thing as -1/2. So that's the gradient for the first one, guys, -1/2. So I know Denise got that. I remember Denise getting -1/2. Talia, I remember you getting -1/2 as well. Rosalie, Shireen, if you don't know how to do it, this is how you do it. It's not that bad. We're gonna do another one after this to practice one more time, then move on. All right. Cool. So Denise, makes sense? Now I understand why you got the -1/2. You did the first one first, right?
Yes, sir.
All right, so we're gonna move on now, guys, from this one. And I'm going to do the midpoint. Cool. M is the midpoint. And we're going to say x1 plus x2. x1 in this case, guys, is 1 plus -1. So a +1 plus a -1 is gonna give you 0 in the end over 2. And then the other one is going to be 3 plus 2 over 2. Cool. And this would give you 0 over 2 and 5 over 2. So you should end up with 0 and 2.5. So I understand why this one was 0 and 2.5. That makes perfect sense. So that's why I feel like everybody was doing the first one, maybe. Yeah, maybe everybody was trying the first one because everybody got kind of 0 for the first one. So Jay was says she's still getting 2.5. You should get 2.5 with the first question for sure, but not the second. I hope everybody following. So is this okay, guys? Make sense? Denise, make sense now?
Yes, sir. That's what I got.
All right, Talia got this right as well. So the last thing now, guys, is the equation of the line. And the equation of the line, guys, we'll have to say y is equal to mx plus c. Remember, m is the gradient, guys, that we found. So y is equal to a negative a half x plus c. And we can use any point. Let's use the first point is 1, 2. So let's use that point. Anywhere I say x, I'm going to put 1. And anywhere I say y, I'm going to put 2. So I'm going to say 2 is equal to negative a half times 1 plus c. And this is going to give me 2 is equal to negative a half plus c, because 1 times negative a half is just negative a half. And then the last thing, guys, I have to carry the negative a half over to the left side. So I'm going to get c is equal to 2 plus a half. So c is equal to 2.5. So the answer for this, guys, for the equation of the line, y is equal to negative a half x plus 2.5. That's the answer for C. Cool. So let me check Talia's answer. So Talia, you're almost here. It's supposed to be 2.5 instead of 2. All right. So guys, you guys want to do one more? Let's do one more. Let's do one more. Let's do one more, guys. I think I just gonna make everybody else do one. I think I just gonna make everybody do one, actually. All right, so guys, let's do one more. We need to try this one more time, just to practice, just in case. Let's look at a question like it. Let's look at a question just like it. Well, no, let me just use one of these and create a new question. Cool. Let's create a new question. So let's say, let's do number 3 and let's call it Talia. Let's say Talia has a line with 2 points and let's put it as 2, 3. And then let's put this as 6 and 12. No, 13. 13. All right, so 2, 3, 6, 13. Cool. No, 13 kind of big. Let me ease it down a bit. Let me put 9. 9 would give me. Okay. All right. Okay, guys. So this is it. A is 2 and 3, and B is 4 and 9. Yeah, B is 4 and 9. Okay. So guys, yes, with these 2 points, A is 2 and 3, B is 4 and 9. Find the gradients, find the midpoint, and find the equation of the line. Cool. Let me put the formulas back on the board. So these are the 3 formulas we need to know. All right, guys. Let's take our time. This one is actually much easier too. So everybody should try this one now, guys. All of us trying the same one so we don't have any mix-ups this time. So these are the three we need to know. We need to know the gradient, the midpoint, and the equation of the line. Cool. So try this, guys. Try this one this time. This one is much easier, actually. Way easier. It's very easy. So everyone, try this one. Jay, Anicia, Denise, Talia, Shireen, Rosalie. Okay, so Rosalie says the midpoint, the gradient is 3. Anicia says 3. Yes, definitely right, Anicia. Definitely right, Jay. And midpoint is 3, 6. Yes, so everybody getting this one right, which is great. Very good. So very good, Rosalie. Very good, Jay. Very good, Anicia. Let me check with Denise. Well done, Anicia. Well done. Let's check if Talia is gone. All right. Usually Talia leave around this time. She usually stay for an hour. 1, 2, 3, 4, 5. Okay. All right. So let me remove Talia. So Denise and Shireen, you are the two I'm waiting on. Shireen, how you feeling? Shireen probably at work. All right. So Denise found C as well. All right. All right. All right. So, all right, cool. So Shireen, you're probably at work, but we're going to go over it now. Let's go over this one now, and then we'll move on. All right, guys. So first thing, guys, we need to find M. And this is x1, y1, x2, y2, right? So how do we find it, guys? of course, we use the formula. So we're going to say 9 minus 3 over 4 minus 2. This should give us 6 over 2, which is 3. So m is definitely 3. The gradient, m is equal to 3. The midpoint is 2 plus 4, which is, this is big M now, midpoint. So this is 2 plus 4 over 2 and 9 plus 3 over 2, which should give us 3 and 6. Cool. So this one is okay. So this one is 3 and this one is 6. All right. And then for the last one now, guys, for the last thing, y is equal to mx plus c, right? M is the 3. So it's y is equal to 3x plus c. And we can use the first point to 3 for the x and the y, right? Hi, Maureen.
Hi,
It's good to
sir.
see you. It's really good to see you. I
We
know you
never
came
know the
late.
time down so far.
Yes, but don't worry. You can watch the recording as well, remember?
Oh,
Um,
okay,
But don't worry, we're going to go into something new after this as well. So
okay.
it's not a bad time to join. So 1 second here, and then let's finish this up, guys. So yes, so guys, y is equal to mx plus c. M is the 3, which is the gradient, and we can use any point on the line to find the c. We're going to always use the first point. Just use a. Always use your first point, which is 2, 3. So 2 is the x and y is the 3. So we're going to say 3 is equal to 3 times 2 plus c, and we're going to get 3 is equal to 6 plus c. Carry this 6 over to the left side, we're going to get 3 minus 6 is equal to c. So c should be equal to minus 3. Cool. So the equation of the line, guys, is y is equal to 3x minus 3. Cool. So that's the answer down here. Y is equal to 3x minus 3. All right. So Denise, I notice you keep not changing the sign. I notice y is equal to,
No, no, sir. That wasn't the issue.
what was the problem? You just never put the minus?
No, I accidentally put, when I'm doing the midpoints, I accidentally put minus instead of plus.
Oh, okay. All right, cool. So as long as you see where you went wrong, then you should be okay. So this should be it, guys. If you have any more issues on this, don't worry. I think I'm gonna do one of these next class too as well. I just want to make sure you guys remember it, because it can come and I really want to know it. So, but we'll have to move on from this now.
Sir, 1 minute, please.
1 minute.
Talking now.
Mhm.
How did you get a -3?
How did I get a -3? 3 times 2, I use this point, 2, 3. And the 3 times the 2 gave me 6. So 3 is equal to 6 plus c. So I have to carry the 6 over to the other side. So because it's positive here, it becomes negative. So it's 3 minus 6. So that c gives you a -3.
You see, because you know what? I keep putting the C where you have the numbers, I put in the letter over there. So when I carry over this 3, it becomes a negative, yes, but the 6 remains positive.
But why would it remain positive?
Carry over is the 6.
Just, well, let's just talk about it. 3 is equal to 6 plus c, right? That's what we have. So if we need to find c, the only way we can find c, Denise, is by carrying the 6 over to the left side. That's the only way. So we're gonna end up with 3 minus 6 is equal to c. So minus 3 is equal to c. C is equal to minus 3, right?
I guess I have to go deep relearning because I normally put the C on the
left side.
yes.
The thing about it though, Denise, is that even if you even if you put the C over to the left side, let's do it. Yeah, let's do it your way. Let's say I put
Right.
this C over to the left side, right?
Mhm.
I would end up with minus C because it can't, once it go over the equal sign, it have to change sign, you know, right?
Oh, yes. Yes.
So
That's
I'm going to end up with a minus C plus 3 is equal to 6, right? If I carry the C over to the left side. Am I right?
No, man, I would have had minus 3 equals 6 minus 3 minus 6 minus 3.
I'm not getting that. All right, let me clear the screen for a second and let me just talk about it before we move on. Cool. So remember, this is what we had, right, Denise? 3 is equal to 6 plus C. Am I right?
Yes.
All right. So let's say I had 3 is equal to 6 plus X. Does this make sense? And suppose I wanted to find X. What would X be? Well, firstly, I can obviously see that X is minus 3. And the reason why I can see it is because 6 minus 3 is the only thing that's going to give me a positive 3. You see what I mean, Denise? 6 minus 3 is the only thing that's going to give me 3. Remember, this equal sign means equal for a reason, you know. It's definitely equal. So what is this unknown value? It has to be minus 3. That's just my common sense, though. But let me solve it without my common sense. Let me say I need to find this X. The only way I can find this X is to say 3 minus 6 is equal to X, meaning I carry this 6 over to the left side of the equation. And if I carry it over to the left side, it's going to change sign. Am I right? So I end up with 3 minus 6 is equal to X. So minus 3 is equal to X. And X is equal to minus 3. Cool. So it's the same thing here for the C. It's not any different.
So
it's the same way.
I keep putting the letter. Put the letter where you put the number. Let me see, please.
Where you put the number. All right, let me try to understand. I'm trying to understand what you're saying. I'm not really understanding it, but let me try one more time.
All right, so it would be where C is 3 would go over there. All right, so when
I get what you mean. I get what you mean. Jay raise her hand. 1 second. Jay. So what you're trying to say is that you want the C on the left side. Am I right? But if I carry this C over to the left side, it's actually going to be negative. Am I right? But another thing you can do too, Denise, is you can just say 6 plus C is equal to 3. This is also the same thing. You understand what I'm saying? So this is the same thing. 6 plus C is equal to 3 is the same thing as saying 3 is equal to 6 plus C. And regardless, any way you do it, you're going to end up with 3 minus 6 as C. C is going to be minus 3. You know? But I think what you're trying to say is you tend to just say this. C is equal to 6 minus 3 and C is equal to 3. But this is not correct. It really isn't. And the reason why it's not correct is because when this C goes over to the left side of the equation, it becomes negative. Do you understand what I'm saying? So even if you did that, anytime any letter or number that goes over this equal sign, it has to change sign. So this would give you a negative C is equal to 3. That's really what it would give you. And if you have negative C is equal to 3, you would have to multiply both sides by -1, basically. And you'd end up with C is equal to -3, same way. You're still gonna end up with this C being -3. You see what I mean? Yeah, so it's just basic. Well, sorry. Well, it is just basic maths, actually.
It is basic, but
yeah. But try not to make that mistake. Like what I'm trying to say is anything that you take and put on the other side of the equation, it cannot be the same sign. So if you have a positive C over here and you put it over to the left side and you put this 3 over to the right side. Another question is this too, then
what I'm going to do, sir, because I don't think at this point I can change. So I'm just going to remember that the letter should be a negative and then I just divide it by -1, both sides. Because it's been a while now, I keep doing the same thing. So
yeah.
I remember that the letter has to change sign. So it
Yeah,
become
the
negative.
letter has to change sign. That's all you have to remember, I think. The letter has to change sign. So once you remember that, you should be okay. Go ahead, Jay. Go ahead, Jay. Jay, look like you're asking a question. I'm back. I'm lost. Where are you guys? Shireen, we're actually gonna start a new topic now. So in chat, thought it was a positive 3 since after a carryover 3, it would be 6 minus 3, not 3 minus 6. So I thought it was positive. Correction. It's the same thing. Jay is saying the same thing. So let's just talk about it one more time, guys. 3 is equal to 6 plus C. What I would do is I always want my letter to be positive. So because I want my letter to be positive, I'd have to say 3 minus 6 is equal to positive C. And I would get negative 3 is equal to C. C is equal to negative 3. That's the way I would solve it. So, right, that's the way I would solve it. But I think what you guys are doing, which you shouldn't do, you can't put this C over to the left side and just say positive C is equal to 6 minus 3. You can't do that because anything that goes over the sign is to change sign. This is the mistake you guys are making. You can't carry the letter, the positive C, over to the left side and it keeps the positive. That's not mathematics, guys. You know, you can't do that. You can't do that. Anything that goes over the equal sign has to change sign, guys. Anything. It have to change sign. Denise, you understand what I'm saying?
Clearly, sir. I knew that, but I don't know why I keep making a mistake.
Sometimes you mix it up, but don't worry, it happens. But just think of it that way. Anytime you carry something over to the other side, it has to change sign. It has to. Another question is this. If you guys say 3 is equal to 6 plus C, and you switch the C with the 3, how come this 3 turn negative and this C don't turn, this positive C don't turn negative? How come this 3 becomes negative, but this one don't become negative too?
So we know that we should subtract on sides, you know. We know that what we do on one side, we should do to the other.
Right. So if this 3 becomes negative when it goes over to the sign over here, how come this just going to remain positive? It can't. It has to remain negative. It has to become negative too, because it went over the equal sign. Make sense? So you'd end up with negative C is equal to positive 3. And as you said, if you divide both sides by -1, you're going to end up with positive C is equal to -3. And honestly, guys, the biggest common sense thing with this thing to me is 6 minus 3 is what gives you 3. So if you got your C as positive 3, you'd end up with 3 is equal to 6 plus C. You'd end up with 3 is equal to 6 plus 3, which 3 is equal to 9. And 3 is not equal to 9. So this would be wrong. And it's kind of really obvious that C has to be -3. You understand what I mean? That's what the equal sign is there for, guys. You know, boy, I feel like I'm stressing this still. Ready to move on, guys? Ready? Yeah, let's move on. Sorry, guys. I think we're taking too long on this. Let's move on to something else. Let's do something else, guys. Let's do something else. I think we did okay with that though, but let's move on to something else. We'll have something else to do. I sent the video into the group as well. All right, guys. So we're doing circle theorem now, guys. So we need to talk about this. We definitely need to talk about this. And this is also going to be pretty active too, guys. So we're going to go through some rules for circle theorems. And let me just take a breather. Take a breather, guys. I think I'm stressing you guys out. I hope I'm not stressing you guys out. Take a breather. Take a breather before we start. God is good. Jesus is king, right? The Lord is good. The Lord is good. Am I right, Maureen? I'm right, Jay? The Lord is good, Jay? Yes. Thumbs up, thumbs up. The Lord is good. All right. I love these thumbs up. I love to see the thumbs up. Shows we're on the same page. All right, guys. So now we're gonna do some circle theorems. We got a breather to just breathe. We're gonna do circle theorem. And guys, why am I doing this? This actually comes on number 9. Question number 9 in the exam in paper 2. Paper 2, question number 9. Always has this in it. Every single time. You're always gonna see this in paper 2, number 9. Every time. So that's why we have to do it. So you're guaranteed to get this on the exam. Guaranteed. All right. And I'm gonna show you some exam questions from it as well. So we're gonna go through some rules, guys. We're gonna go through some rules. So guys, circle theorem is about circles. So every circle, guys, has a center. Okay. Every circle has a center. And if you had a compass, you could draw a circle like this, right? At the center. Make sense? So every circle has a center, okay, guys? And we need to talk about two things. So if a line goes through the middle, the center, guys, the line goes through, it touches one edge and goes through the center and touches the other edge. This is called the diameter of a circle. You guys should already know this though. That's called the diameter of a circle. And from a point from the center to the edge, which is half the diameter, is called the radius. Cool. We should know this already though. So the radius is always like this, guys, from the center to the edge, and the diameter is 2 times the radius, right? A diameter is basically 2 radiuses, okay? So this down here, guys, this long one you see is called the diameter, D, and the short one is called a radius, R. Cool. Maureen, you with me? You with me, Maureen? Make sense? You understand what a diameter and a radius is? Rosalie, Shireen, Anisha? All right. Yes, sir. All right, cool. So we know these stuff. Maureen, I hope you're with me. Jay, we know what these stuff are, right? Some basics, just some basics. Oh, Anisha on our call. All right. So just some basics for the circle, guys. We'll have a radius and we have a diameter. Cool. Remember, you can always watch this video. All right. So guys, some other information we need to know. A line that you draw through randomly through the circle, guys, is called a chord. Cool. So if you draw a random line from here to here, guys, that's called a chord, right? It doesn't go through the center. The chord never goes through the center because if the chord went through the center, it would be a diameter. So it doesn't go through the center, but a random line inside the circle is just called a chord. And in here, this shaded region in here, let me make it yellow. The shaded region inside there, guys, is called a segment. So the shaded region inside here is called a segment. So you can only get a segment, guys, from drawing a chord. And if you draw a chord, guys, the area that I'm shading here is called a segment. Cool. So kind of simple, just some information we need to know about the circle. All right. So that gives us the basics. Just the basics so far. Cool. Guys, if you have 2 radii drawing from the center of the circle, let me just show you. If you have 2 radii, guys, like a pizza shape here, that's called a sector. So a sector is different from a segment, guys. A sector would have to be from the center of the circle, while the segment is just from a random chord. Cool. So here, this yellow part over here, this part is a sector, like a slice of pizza. And then over here is just what you call a segment with a random chord. Cool. So these are just some basics though. It's not really that important to know, but those are some basics. Another thing to guys, if you have a random point on the outside here, these lines that you see that touch the edge of the circle is called a tangent. Cool. So that's one thing that's important to know. So these are just some general stuff, guys, that we need to know. But now we're going to look at some rules that we need to know. All right, some rules. And this is the first rule, guys. It's a very simple rule. I kind of like this rule, to be honest. So it says here, angles at the center is twice the angles at the circumference. Cool, so I'm gonna give you an example. So if here is 50 degrees, then here is 100 degrees. Does that make sense? So this is the first rule that we need to know for circuit theorem, guys. This is the first rule. So if we have this, like how you see here, guys, angles at the center is 100 degrees, and the angle here is half, 50 degrees. Make sense? Yes, I hope it makes sense. So I'm going to give somebody an example now, right away. Angles at the center is twice the angle at the circumference. So yes, so let me give somebody an example. If here is 150 degrees, Denise, how much is the angle up here? So if B is equal to 150, how much is the angle up top?
300.
No. This one is the big one. This one is a small one. So the one up here, the A up here, should be half 150 divided by 2. So it should be 75. Make sense? Make sense, Denise? So angles at the center, which is a 150, is twice the angle at the circumference. So the one here at the edge up here, guys, is always half the one in the middle. Make sense? The one in the middle is always 2 times the one at the edge. Denise, don't worry, Denise, you're gonna get another example. Let me give somebody else an example now. So let me ask Jay. Jay, ready? So Jay, if this angle A here up the top is 60 degrees, how much is the angle at the center? If A is equal to 60 degrees, how much is B, the angle at the center? All right. 120. All right, well done, Jay, well done. Well done, guys. Cool. And then let me ask somebody else now. Let me go to Anicia, maybe. Well, Anicia said she was on a call. Let me ask.
I'm off the call now.
All right. So Anicia, if here is 90 degrees, how much is the angle here?
45.
45. All right. Well done. Cool. So we're getting it. Maureen, if here is 50 degrees, how much is the angle here? Maureen, you with me?
You hearing me? 100.
Okay, 100. All right, guys. So we're getting it. We're getting it. Okay. And let me ask someone else. So guys, let's do this one over here. It says, what the hell? What in the world? What the heck? Wow, guys, I have no idea what the heck is happening. Wow. Hey guys, it seems I had a short power cut here. Can everybody hear me?
Yes, sir.
Oh, sorry about
Yeah.
that. Seems I had like a short power cut. I'm so sorry about that. All right, guys, so let's do this one over here, and I'm going to ask Shireen. Let me ask Shireen. So it says if AOC, which is the angle at the middle here, is 96 degrees, how much is ABC, which is the angle here? Remember, guys, anytime they say it this way, the angle is always at the point in the middle. So AOC is A to O to C, and ABC is A to B to C, right? So Shireen, if here is 96 degrees, how much is the angle up here? All right, Shireen not with me. Rosalie, you want to help me with that one? Oh, Shireen said 48. Yes, yes. Yes, so well done, Shireen, well done. Well done, Shireen. Yes, so if there is 96 degrees, that guys, up here would be 96 divided by 2, which is 48 degrees. All right, so well done, Shireen. I really like that, Shireen, well done. 40 times 2, yes, yes. So if here is 96, guys, it might look a bit different from this one on the left, but it's still the same concept, guys. The angle at the center is twice the angle at the circumference. So that's the rule. Okay, guys. So that's a general rule. Let me do one more. Let's do one more. Okay, guys. So it's saying here ABC is 44. So this angle is 44. So if this angle is 44, guys, let me ask somebody in the chat. Let me ask Rosalie. So Rosalie, if up here is 44, how much is the angle at the middle?
Sir, 88.
88. All right, guys. So it's kind of simple. Believe me, watch this video. It's a very, very good video on this topic, and it will help you a lot. And we're gonna go through a good amount of them. Cool. So we're good, guys. We kind of get the concept of that one now, so we can just move on. And you can go through this video and look at the answers as well. So another one now, guys. Another one now. It's the same concept, guys, but it's a little different, just a little different. So it says angles in a semicircle contain a 90-degree angle, right? This is just rule number 1 with angle at the center 180. So it's very similar to rule number 1, guys, but it's different. Rule number 2 is angles at the semicircle contain a 90-degree angle. What does that mean, guys? If you have a line going through the center, this is one of the easiest ones, guys, to pick up. If you have a line going through the center like this, any point that you draw on the edge of the circle is going to be 90 degrees. So here is going to be 90 degrees. Here is going to be 90 degrees. It's always 90 degrees if you draw 2 lines from the diameter. Cool. So yes, guys. So if we have 2 lines, just like what we see here, anywhere you draw those 2 lines, guys, it's going to have a 90-degree angle everywhere. And it's very common. It's a very common one to pick up. It's really easy to see and pick up. If you have a diameter here and you have lines like this, it's going to be 90 degrees. Cool. And the reason why they say it's similar to the last rule, guys, is because 180 is right here and here is 90 degrees, which is half, just like the last rule, but it's a little different. Cool. So let me ask somebody really quickly. Let me ask Jay. So Jay, oops, I kind of give you the answer already. But Jay, if you have a line running through the center like this, how much is ABC, right? How much is the angle right here? I think it's kind of easy to see. It's really easy. I like this one. This is my favorite rule, to be honest. This is by far my favorite rule. So how much is the angle right there, Jay? Are you with me? Talking in the chat. Not seeing Jay. Denise, how much is the angle right there? Denise, you would?
Is it 90 degrees?
Yep, it has to be 90 degrees. And the reason why it's 90 degrees is because, of course, the 2 lines are drawn through the diameter. Anytime you have these 2 points from the diameter, it's 90 degrees. So I can give you another example, guys. Suppose I had it here and here. Up here would also be 90 degrees. Cool. It's always 90 degrees, guys. Let me see if they have any more examples. I think it's really easy though. This one is an easy one. 90 degrees. Do they have any more examples? Okay, I like this one. I like this one, guys. I like this one. Okay, so let me ask Denise, you ready? Let me ask you again. So guys, remember here is 90 degrees. So Denise, if here is 44 degrees and here is 90 degrees, how much is this angle here? BCA. How much is the angle up there? Denise, you with me?
So can it be 46?
I think it's 46 now. And the reason why it would be 46, guys, is because 44 degrees plus 90 degrees plus this angle up here, let's call it C, should be equal to 180, right? Make sense? So guys, 180 minus the 90 degrees minus the 44 degrees will give us 46 degrees, right? So up here has to be 46 degrees if here is 44 degrees, because angles in a triangle add up to 180, right? So 46 plus 44 would give us 90. 44 plus 46 plus 90 would be equal to the 180. Cool? Make sense, guys? I don't think it's too bad. I think it's manageable. All right, so let me ask Rosalie. Rosalie, you ready for one? Let me try. So make sense, guys. If here is 44, here is 90, and we don't know up there would have to be 46 because angles in a triangle add up to 180. 44 plus 46 plus 90 would give us the 180. Cool. Okay, let me give somebody else a question. Let me change these values though. So let me change this to 36 degrees. And let me change this to 36 degrees. And let me ask somebody else. So Shireen, are you with me? I hope Shireen is here. So Shireen, if here is 36 degrees, obviously here would have to be 90 degrees. How much would be X up here? Everybody with me? Shireen? Not seeing Shireen. Let me ask Maureen. Maureen, you want to try? Anisha
Sir,
said
you hearing me?
54. Well done. Yes, go ahead now, Maureen.
9, 10, 11, 12.
So here is 90. Here is 36 degrees. What would be up here? Anisha, well done, by the way. Well done. Seriously. Give yourself a pat on the back.
54, sir.
Yes, it would be 54. And the reason why it's 54, guys, is because 36
And 54
plus
and 90.
54 plus
And
90
make it
would give us the 180,
180.
right?
Okay.
So this is a good rule to remember, guys, because sometimes they might ask you to find an angle in the triangle. Cool. All right. So guys, let's move on to the next rule now. So that's rule number 2. Moving on. Let's move on to rule number 3 now. So I kind of like rule number 3. It's kind of simple. So guys, let me just draw the circumference right here. So rule number 3, guys, says angles from the same arc at the circumference are equal. What does that mean, guys? This arc right here, that pink arc, if you draw 2 lines from those arcs, all of these are gonna be equal. So all of the 3 you see me drawing here are equal. If I draw another one up here, it's equal as well. Let me just make that area red. So if all of these are equal to each other, guys, all of them are equal to each other. So up here is equal. So all the red areas you see here, guys, are equal. And why are they equal, guys? They're equal because the lines are all drawn from the two same points on the circumference, the two same arcs. Cool. It's a weird one, guys, but it's kind of easy. You'll get used to it. Believe me, you get really, really used to it. Believe me. So I'm gonna draw an arc right here. I'm gonna show you guys where the arc is first. And I'm going to ask Denise. Denise, you ready? If here is 50 degrees, Denise, how much is up here?
Same 50, sir.
Same 50, same 50. Well done, Denise. Thank you so much, because they're on the same arc, right? The lines are coming from the same arc, same 2 points. Notice, guys, same 2 points. Cool. So let me do another one now. Let me change it. All right, and let me draw a blue arc. Let's make it blue. So this arc is down here instead. And I'm going to ask Anicia, if here is 40 degrees, Anicia, how much is here? Anicia, you with me? Not seen Anicia. Let me ask, okay, 40. Jay says 40. Well done, Jay. All right, Jay, well done, well done. So Jay says 40. So Jay answered for me. I like that. Let me move on and give somebody else a question as well. Let me make this red. So suppose I have here as 30 degrees. How much is here, Rosalie? Rosalie, you with me? And you see you're gone, not sure. 30, all right, making sense. So you guys see it, because they're on the same arc, they're the same. And Denise asked, Denise already, let me ask Maureen. So Maureen, if here is 45 degrees right here, how much is here, Maureen?
45.
All right, yeah, man. It's not so bad, guys. I like this rule. It's really not so bad to see. All right, so Anicia is back. All right.
Sir, but reporters asked me the question.
It's okay. Let me ask you another one. Anicia, you ready?
Yeah.
So if here is 60 degrees right here, how much is over here?
That would also be 60 because they're touching the same arc.
All right, so that's how it goes. That's how it goes, guys. Remember, it's the same arc. This is the arc. So that's why they're the same. So these two would be the same, and these two up here would be the same. Let's call it, if here is 40, and here is also 40. Cool. So it's not too bad. Let's see some other questions that they have. All right, so let's do that one. Let's do that one together, guys. So, okay, so DAB. So if here is 44, guys, and ABC, if here is 60, I'm gonna ask you guys. So if here is 60 degrees and here is 44, let me ask Denise. Denise, how much is over here?
$60 degrees, sir.
Well done, well done. And Jay, how much is over here? You can type in the chat, Jay. All right, 40. Okay, cool. So we're getting it, guys. I think we're doing well. I think we're doing well so far. Cool. So we're good. We're good. DCB is equal to 44. And the other one is equal to 60. Perfect, perfect. So the next rule, guys, is angles in a cyclic quadrilateral. That's what the rules are. And it's kind of easy rule, guys. It says opposite angles in a cyclic quadrilateral. So guys, if you have a quadrilateral inside a circle like this, a four-sided polygon, inside the circle like this, guys, the opposite angles are equal to 180. So let me just show you what I mean. So guys, you have an angle here called D, and you have an angle here called B. D plus B is equal to 180. Cool. Same thing here, A plus C is equal to 180. Cool. And of course, all the angles add up to 360. Cool. So this is not too bad of a rule. I'm gonna ask everybody one of them though. So Denise, you ready? Ready, Denise?
Okay, sir.
All right, so if here is 84 degrees, Denise, how much is over here? And let me ask J1 as well. So J, if here is 102 degrees up top here, how much is down here? So this is yours down here, J, and Denise, this is you over here. Remember they add up to 180, guys. Remember the two angles should add up to 180.
Sorry, 96 degrees.
96. All right. And J, you want to work it out again? You said 102, but think about it, Jay. Remember they add up to 180. So if up here is 102, then that would mean 102 plus here, let's call it A, is equal to 180. So remember the both of them add up to 180. So if it was 102 again, then it wouldn't add up to 180. It would be more than 180. Okay, 78. Yes, so it would definitely be 78, guys. So here would be 78, and here would be 96. Am I right, Denise? Make sense? Shireen says 78. All right. 78. All right, cool. So guys, it making sense. Believe me, guys, we're gonna get good at this. We're gonna get very good at this. Cool. Thank you so much, Jay. Well done. Thank you so much, Denise. So guys, let's do some more now. Let me ask Anicia. So Anicia, if here is 95 degrees, how much is up here? So that's yours, Anicia. And if here is 99 degrees, how much is over here, Rosalie? So Anicia says 85. Well done. Well done, Anicia. So here would be 85. 85 plus 95 will give you 180. So well done. And Rosalie, you with me?
Yes, sir. 81.
81. All right. Well done. So here would be 81. And we have two people left, Shireen and Maureen. So 81. Well done. Well done. And the last two, I'm going to give to Shireen and Maureen. Okay. So that everybody remember this rule. So if right here is 93, how much would up here be, Shireen? And Maureen, if here is 77, how much would here be? $87. Well done, Shireen. Well done, Shireen. Well done. Up here would be 87.
Is it 143, sir?
Well, it would be 180 minus 77.
77.
Yes. So it would be 103.
103. Oh,
Yes, because
yes,
103
103. 103.
plus
Me no get
77 will give us the 180.
103. Yeah, 103.
Yes. All right. Don't worry, Maureen. Well done. Well done. 103. All right. Cool. So we're good. We're good with this rule, guys. I think this rule is okay. Just remember that these two angles must add up to 180. The corresponding ones. Cool. These two must add up to 180. Simple rule. All right, we're making good timing, guys. We're making good timing. And I like how this class is active today. Well done, Shireen. So let's move on to the next one. Next rule. Understand that rule. So guys, this is a weird rule. It doesn't really come up very often, but it's kind of simple to see though. Let me just show you. So guys, if you have a triangle like this, and you have a tangent from the triangle, like this shown here, the angle here, guys, this angle right here is equal to this angle up here. And this angle, guys, this angle in here is equal to this angle out here. So I'm gonna ask everybody this one. It's a weird one, so, and it doesn't come too often on the exam, but I still have to ask you guys. So let me ask Shireen. Let me ask Shireen first. Okay, so Shireen, if here is 18 degrees, how much is down here? If up here is 18 degrees, how much is down? How much is in here? Right, this space right here. Shireen? Shireen, are you there? Not seen her. Let me ask somebody else then. Anicia, if up here is 18, how much is that little space down here? This space right here.
18.
18, makes sense. It should be 18. So if up there is 18, guys, here is 18 as well. This space right here. Cool, it's kind of simple. And then let me move on to J now. So J, if right here is 109, this area here, how much is this area right here? Jay, you with me? Jay? Let me ask somebody else. Let me ask Denise. If here is 109, Denise, how much is right here?
109, sir.
109. All right, 109. That's how it works. Let me ask another one. Let me ask Maureen. So Maureen, if here is 20 degrees, this small space here, how much is up here?
20, sir.
20. All right. And let me ask another one. If here is 100 degrees in here, how much is out here, Rosalie?
100 degrees, sir.
All right. So guys, you see, it's a simple rule. It's not too bad. Here, down here is equal to up here. And this one over here is equal to that one over here. Cool. It doesn't come too often, but it's still good to know. All right. Cool. And then last two rules. The last two rules are important, guys. They're very important. So the last two rules, guys, the last two rules are a tangent and a radius meet at 90 degrees. So anywhere you have a tangent, guys, if you draw a tangent on the outside of the circle like this, it always meets the radius at 90 degrees. So here is 90 degrees and here is 90 degrees. And the other one is, guys, if you have a tangent out here, well, let's just look at this one first. So this is the rule, guys. So if we have a tangent, let me just show you what I mean. Let me draw a circle over here. And guys, suppose I have a point outside of this circle like this here. Cool. Yes, so that's my circle. And let me draw the points. So this is a point on the outside, guys. If I draw a tangent right here, right? And I draw a tangent right here. So the tangent is basically there. If I draw from the radius, guys, to the where the tangent is, that's always going to be 90 degrees. Cool. So here's a 90-degree angle. And here is a 90-degree angle as well. So that's what they're asking you for. I'm gonna show you guys how to use this rule soon. Cool. So that's what it says here. A tangent and a radius meet at a 90-degree angle. So they always meet at a 90-degree angle. Cool. That's rule number 6. And then the last rule, guys, is that two tangents to a circle from the same point are equal in length, meaning that they're the same length. So this over here is the same length as this over here. Same thing with this one, guys. Let me make it blue. These over here, this line right here is equal to this line right here in length. The tangents, no matter where you put the point, guys, they're gonna be the same length. So let me just show you an example, guys. Let me make this dark blue. If I put the point over here, for example, and I draw my tangent to the circle again, they're still gonna be the same length. You notice, guys? You notice they end up the same length? Well, that one don't look right. Yeah, like that. Yes, they're gonna end up the same length, guys. Here and here are equal to here and here. It don't matter where the tangents are, they're always going to be equal. It don't matter where the point is. The point can be over here as well. The point can be down here, guys, as well. If I draw two lines that are tangents to the point, they're always going to be equal. The lines are gonna be equal. Cool. All right. So guys, these are kind of weird ones, but let's just finish strong. Let's finish strong, guys, and look at some questions here. Cool. Let's look at some questions here, guys. Let's look at the questions that they have. Okay, so let's look at this question. Let me do it for you guys really quickly. So this question says, PT is a tangent to the circle. So yes, this is definitely a tangent, guys, right? And remember, guys, the tangent always meets the radius at 90 degrees. So here is 90 degrees for sure, because of the rule that the tangent always meets the radius at 90 degrees. Cool. And it says here that right here is 54 degrees. Cool. It says find the angle, the size of the angle T to O to U, which is this angle here. So they're asking you to find this angle. Cool. So it's a good question still, guys. It's a good question, but it's not too hard to answer. And the reason why it's not too hard to answer, guys, is because this angle here, remember right here, guys, is supposed to be 90 degrees. Right here is supposed to be 90 degrees. So if right there is supposed to be 90 degrees, guys, then 54 minus 90 should give me right here. And how much is 54 minus 90? 36 degrees. So here, guys, is going to be 36 degrees. Cool. Makes sense? Because 36 plus the 54 give me 90. Right? So here has to be 90 degrees because it meets the tangent at the radius. Cool. So if here is 36 degrees, guys, then guess what, guys? Up here is 36 degrees as well. And the reason why it's 36 degrees too, guys, is because it's two radii. So this is one radii and this is another radii. So these are the same length. So these are isosceles. These are two the same length. So if here is 36 degrees, guys, up there is also 36 as well. So the angle in here, guys, would be 180 degrees minus 36 minus 36. And that would be 180 degrees minus 72, which would just be 108. So the angle right there, TOU, is equal to 108 degrees. Cool. Denise, talk to me.
Yes, sir. Okay.
How do you feel about this, Denise? It's okay?
Yes, sir.
Maureen, how do you feel about it?
It's okay, sir.
All right, Jay, not so bad. Anisha? Thank you, Jay, for the thumbs up.
So
Rose?
one question, sir. Basically, if you get something like this, just look at the triangle that is inside, because you all know that a circle right up to what, our 360.
Yes, the circle is up to
Just pay
3. The
attention
circle,
to
but
the triangle in the circle.
yes, yeah. Pay attention to the stuff inside the circle and the
Right.
rules. Yeah, man. Rosalie, Shireen, do it again. All right, let me do it one more time. So, Shireen, main thing is, number one thing, guys, is that this is a radius and it meets the tangent right here. So here has to be 90 degrees, that area here. So 90 minus the 54 would give us 36 degrees. So here has to be 36 degrees, guys, because 36 plus the 54 would give us a 90-degree angle. Right here has to be 90 degrees. And because this radius is the same length as this radius, both of these are the same length, then this angle would have to be 36 degrees as well, because that's how isosceles triangles are. And then 180 minus the 36 and 36 for the triangle will give us the 108 on the inside here. So inside here will be 108. Cool. And the good part about it, guys, is you can watch this video for the solution. 26. Well, they use a wrong number here. This is not 26. It should be 36. Yeah, they use the wrong number here. Man, what a bad example. But it definitely should be 36, guys. I guess they made a typo in the question. Yeah, they made a typo, man. They made a typo for sure. 20, yeah, 54 plus 26, 6 plus 4, 1. No, this gives us 80. Yeah, they made a mistake, guys. So it should be 36 for sure. 36. And this should be 108. So they made a mistake. I'm not sure why they made a mistake in the video though. But it's okay. Sometimes people make mistakes, but no worry, guys. Just try to remember it's 108. And this one, guys, is also a good example as well. So this is covering the same rule, guys, that the tangents are equal. So this one is kind of easy to, guys. We'll have to look at the triangle here. It says right here is 68 degrees. So if here is 68 degrees, guys, then they're asking us to find PAB, which is the angle right here. But the angle right here, guys, would have to be 180 minus 68. The angle here, and the angle here has to be equal to the angle here as well, because it's an isosceles triangle. These two sides are the same. So these two angles here have to be the same. Cool. So 180 minus 68, guys, would give us 112 degrees. So these two angles here, when you add them together, it would be 112. And if we divide this 112 by 2, I think we're going to get 56 degrees. Yeah. So up here, the angle they're asking for, PAB, is equal to 56 degrees. So up here is 56 degrees, guys. And down here is also 56 degrees because it's isosceles. Cool. Very similar to the last question. Very similar. And let's look at the result, 56. Yeah, man. So that one is right. That one is right. Cool. So let me ask again. Maureen, you understanding why
sir.
both of them is 56? Denise?
Yes, because the as you say, it's the isosceles triangle,
Yes, yes.
and it adds up to 180. So one angle already is.
Yes, once you get one angle, you get the other in this case. Denise, it makes sense to you? Jay? Anisha?
I'm here.
Rosalie, Shireen.
68. So you're going to take away
Yes, sir. So if you get
Yes.
one angle, you basically
Use it
take
to
away
find the others.
use that to find the others. So you take away the
Yes.
68 from 180, and then whatever you get, you just share it up between the other two.
When it's isosceles, yes. When it's isosceles
When
like
it's
this,
isosceles.
for sure. Yeah, man. So 1 second, guys. Let me just give me 1 second. Hold on. All right, guys. So cool. So this is okay. All right, guys. So what I'm gonna do now is I just went to use the bathroom. Sorry about that. Okay. So what I'm gonna do now, I have 15 minutes left. So what I'm gonna do, I'm gonna try to go through some stuff. So I sent some stuff into the group as well, guys. And don't let it overwhelm you. What I want to do this week, especially because tomorrow is a holiday, I think maybe Anicia might still be working though, and Jay might still be working.
Yep, still have to.
Yep, I have work too, guys. I have work too. So I know how you feel. I'm not sure about Rosalie and Shireen, but what I did is I sent paper 1, paper 2, and paper 3 into the group. So I sent you guys all the papers just as a reference, the latest papers, just as a reference to say you guys should print them. I think you should print them. So I sent you guys January 2020 paper 2, January 2021 paper 2. I sent you January 2019 paper 3, and I also sent you a multiple choice set May 2019, and I sent you the solutions as well. So I didn't just send you the papers. Work for me tomorrow, sir. So everybody basically have work same way then. All right. So I sent you the solutions though. And the reason why I sent you the solutions is because I want us to go through those papers as a reference. So I sent you this paper, guys, 2021, and I also sent you the solution. So you can look at the solution as well. Cool. But I'm gonna go down to same question 9 to show you that this just comes every year. See it here, guys? Question 9, geometry and trigonometry. And they always come with a circle theorem question. So this is the latest paper, January 2021. And it says the same thing, guys, geometry and trigonometry. And we're going to use the rules to solve this one. Okay, guys, let's use the rules. Ready? Let's try this one before we go, all right? Let's use the rules to solve them. So it says in the diagram below, A, B, C, and D are points on the circumference of a circle. And it says here, BOD is a diameter. So this here is a diameter, guys, for the circle. And AOC is a diameter. So here is also a diameter as well. And it says A, B, and DC are parallel. So they're trying to say these are parallel. Here is parallel. Cool. So it says here, state why the reason why ABC is 90 degrees. Cool. So they said, guys, state why ABC is 90 degrees. I think this is a good question. And I'm going to ask Denise. Denise, why is up there 90 degrees? Denise, you with me? Not seeing Denise.
Yes, sir.
Yes.
Because angles on the same are at the circumference it is equal.
Well, remember the one that said angles in a semicircle? Remember that one, guys? Angles in a semicircle. It's the same rule, but remember the one that said angles in a semicircle?
Angles in a semicircle contains 90 degrees.
Yes, add up to have a 90-degree angle. That's the one that they're asking for. That's the one that they're asking for, guys. So you want me to go back to the rule for a second? Let's go back for a second. Remember this one? It's very similar to the second rule, the first rule, but remember this rule, Denise?
Yes,
Remember
sir.
it? It's the
Yes, I
same
do.
rule. So if you look, you can see here that this is a diameter. And if you draw two lines here and here, obviously there would have to be 90. You understand what I mean? So angles in a semicircle add up to 90 degrees. So that's what you'd write. So for your 1 mark, just say angles in a semicircle. In a semicircle add up to 90 degrees. Cool. That's it. That's the answer for that one. Cool. And then, cool. So that answers the first part. It's really simple, guys. Really simple. Because remember they have a diameter here. So 90 degrees, definitely 90 degrees up there. So I don't think that was too bad. I think that was okay. So that was rule number 2. And the next one now, guys, it says, determine the value of each of the following angles and show detailed working where necessary and give a reason to support your answer. Okay, so they said BAC, guys. So angle BAC, guys, is actually B to A to C. So they're talking about this angle here. Let me just write that over here, guys. So they said BAC. So guys, anytime they say BAC, they mean B to A to C. So the angle is right here. Cool. So they're asking us to find this 2P in here. Cool. Make sense? Yeah, they're asking us to find that angle there. Right. Yeah, they're asking us to find the angle there. Does anybody have any ideas for how to find the angle? Anybody have any ideas? I have a good idea still. Man, I hope this is not too hard to you guys. I hope I'm not throwing you in the deep end. But guys, they're asking us to find that angle over here. So guys, I actually think it's 45 degrees. Let's look at the solution too. Let's look at the solution too. I think it's 45 degrees for sure. Yes, it's 45 degrees. And the reason why it's 45 degrees, guys, is because here is 45 degrees and here is 45 degrees. That's why these are two radiuses. And this angle is actually equal to this angle over here. Cool. So over here is 45 degrees as well. But let's look at the solution still. Let's look at the solution. I'm just trying to make sure we're on the same page here. This is not an easy one still, but let's look at the solution, guys. Let's look at the solutions for the same paper. Okay, so the first one is 90 degrees because it has a diameter. Part 2, BAC is equal to 2P plus 3P is equal to 90. All right, well, that makes sense now still. That make whole heap of sense. All right, so let's look at it now. Ready, guys? Everybody with me? Let me check with Denise. Ready?
Ready, sir?
All right. So guys, we're going back to the same thing we were doing before. So the angle up here is 90 degrees, right? Does that make sense? Am I right, guys? Angle up here
Yes,
is
sir.
90 degrees. And here is a triangle, am I right? Here is a triangle. So we can see that there's a triangle right there. Am I right, guys? Make sense?
Yes, sir.
So if up here is 90 degrees, then that would mean 90 degrees plus here, which is 2p degrees, plus here, which is 3p degrees, would be equal to 180, right? Make sense, guys? It's very similar to what we just did a while ago. Very similar. The only difference is that they have here as 3p and here as 2p. So it's not an isosceles triangle, but it's still a triangle. Am I right? So if we need to find the 2p, we need to find what p is first. So we're going to end up with 5p. 2p plus 3p will give us 5p is equal to, well, no, let me add it up. Sorry. 90 degrees plus 5p would be equal to 180, right? So I'm going to do this. So carry the 90 degrees over to the right side. I'm going to get 5p is equal to 180 degrees minus 90. And 5p would be equal to 90 degrees. Cool. So if I divide both sides by 5, guys, I would find my p, and p would be equal to 18 degrees. Cool. Make sense, guys? Making sense? I think that makes a lot of sense. Kind of rough. Kind of rough to throw you guys
The
through.
answer, sir, the answer is 18.
No, the p is 18. The p is 18. So they asked us for the angle here, guys. Let me change the color. Maybe it's kind of. They asked us for the angle right here, the 2p. So 2p, guys, 2p would be equal to 2 times 18 because p is 18. So 2p, which is the angle, the BAC is equal to 36 degrees. So here is definitely 36 degrees. And over here would be 3p, which is 3 times p. And 3 times p, 3 times 18 degrees is actually 54 degrees. So for the triangle, guys, here, the 2p over here is 36 degrees. And over here, the 3p is 54 degrees. Does that make sense, guys?
54.
Yeah, 3 times p, it says 3p, and here is 2p. So we found the p. So 2p would be 2 times p, which is the 36 degrees. And 3p would be 3 times 18, which is 54 degrees. Make sense? Does that make sense, guys? I hope so. Jano, I feel like I'm throwing you guys into
Sir,
too much too
please
soon.
don't delete it, please.
No problem, no problem.
Alright.
I think I'm throwing you into too much too soon. Maybe next class I need to do more of these. So honestly, guys, next class I'm not moving on from this. We need to do some more of it. We'll definitely do. So next class, guys, I'm really going to try and review what we did earlier, the same gradient of a line, gradient, midpoint, and so on. And then we're going to do some more circle theorems. Cool. All right, guys. So not gonna remove it yet, but it's still the same concept, guys. The concept about it is many of the times it's really a triangle you have to solve for. They give you one angle, so you got this angle as 90. Here is 2p, here is 3p, so you'd have to put that to 180 in order to find the other two angles, right? In this case, they put the angles as a variable. So when we find the P itself, then we have to multiply it by 2P to get that one and multiply it by 3P to get the other. But it's usually two angles in a triangle we need to find a lot of the time. A lot of the time. A lot of the time. So guys, they asked us, why is up here 90 degrees? It's 90 degrees because of angles in a semicircle always add up to 90 degrees. And here's a diameter. Sorry. Yeah, angles in a semicircle always add up to 90 degrees. And here is a diameter, guys. So if here is a diameter, then any 2 points we draw along the circumference would give us 90 degrees. In this case, it's just in the middle though. So here is 90 degrees. And if here is 90 degrees, guys, then that means these two angles, 2P plus 3P plus 90 would be equal to 180. When we solve for that, we're gonna get P is equal to 18 degrees. So here is 2P, which is 36. 2 times 18 is equal to 36. And 3 times 18 would be equal to 54. So over here is 36 degrees. Over here is 54 degrees. Cool. So don't worry, guys. We're gonna do this again. We're going to do the first thing we did in class again too. One more time. I need you guys to really get this. I definitely want to go over these again. So it says find angle BAC. BAC is 36 degrees. Why? Angles in a triangle. Add up to 180. Angles in a triangle add up to 180. So when you work out the stuff in the triangle, guys, you don't get it fully. I understand, Shireen. I understand, Shireen. We're going to do a lot more. Next class, circle theorem. We're going to continue with this. Cool. Yeah, we need to continue with this next class for sure. So I think we might stop here. I think we might stop here though. So here is 36 degrees. Another thing they ask us for, guys, is angle Q, which is the angle down here. Cool. They ask us for the angle down here, guys, this Q over here. So yes, they ask us for this Q over here. How would I find that Q, guys? It's kind of obvious. Sorry, it's kind of obvious that this Q is 54 for sure. Because here is 36 degrees as well. Here is 36. But because of, guys, anytime you have two parallel lines and you have a Z, anytime you have two parallel lines like this, guys, and you have a Z, the angle in here is always the same. So if here is 36, guys, then here would be 36. So if here is 36, guys, then right here is also 36. Yeah, right there is definitely 36. Cool. Yes, yes, right there would definitely be 36. Hold on. Q is equal to 2P. Let me just check it. Q is equal to 2P. Let me just double check that. Oh, no. These are definitely the same. Sorry about that. Whoa. Let me just double check. So guys, hold on. Oh, let me just talk about this one more time. Ready? I hope everybody's with me. It's kind of getting late now. Still class basically done though. But guys, let me just draw an arc right here. Yeah, guys. So because these are along the same arc here, here would be equal to here. Does that make sense? So if here is 36, guys, if here is 36, then here is 36 as well.
Yeah.
Does that make sense? Denise, it makes sense to you?
54.
Yeah. And
Yes,
here
sir.
would be It really make a lot of sense to me. Makes sense to me. And if here is 54, is there 54? No, that's not 54. Here is 54. Here is 54. Yeah, so these would definitely be the same. So this Q is definitely equal to the 2P. So here would be 36. 2P is 36. So Q is equal to the 36. Cool. For sure. Definitely for sure. So since here is 36, then here is also 36 because of angles are on the same arc. For sure. Cool. Yes, for sure. But I also think the R is equal to 36 though. Yep. R and Q are the same. Yes. So let me go back to it. So yes, guys, here is 36 because angles are on the same arc. Cool. But here is also 36 too, this R. And the reason why that R is 36, guys, is because the same thing I was just saying. Angles in a Z on two parallel lines. Remember I said that here is parallel to here. So angles in a Z, guys, these angles are always going to be the same. So here is 36 and here is also 36. Cool. So if right here is 36 along this Z here, then the R is also 36 as well. So right here is 36, but here is also 36 as well. Cool. So guys, I'm so sorry to keep you guys past 6 as well. I don't like to keep my classes too late or too long. But what I'm gonna do is, guys, I think what you guys should do is review the rules. So watch this video again in particular. Believe me, it's gonna help you more than you think. So this video here, I'm gonna probably send all of you guys again. Watch this one for the rules. And then next class, we're gonna start right here again. I want to go through this same question again. And we're gonna go through a couple like these. Cool. All right. So you got to go. I understand. All right, Shireen. So I'll see you guys on Thursday at 6 p.m. And of course, guys, please, I'm begging you for the stuff that I gave you. I sent some stuff into the group. Just print those papers because we're gonna be going through them. So print them from now. I gave you the solutions with them as well. Print all of them from now so that you have them as reference for when we start to go through them. Cool. But for now, please, guys, just do a review of what we did this class. Look through the circle theorem video to remember the rules. Look through the same questions here. And then next class, we'll go again. Next class, we'll do this again. I want to do one more of these next class. And then we'll go into the circle theorems again. We're not going to move on from these two topics. I want you guys to get them. Cool.
Yes, sir.
Yes. So guys, thank you guys so much for coming. If you need any help, just let me know. Do you guys want me to send you some circle theorem examples? Maybe. Do you guys want me to send you a video with some examples?
Yes,
Let me
sir.
check. Yeah, let me check one with examples for you. Probably find a CXC one, to be honest. I want to find a CXC one in particular. I want to send you guys some examples. Just the next class, it won't be so hard. Circle theorem practice. Maybe I'll send you one of these videos. Let me check this one. All right, cool. I might send you this one, to be honest, because this one don't look too bad at all. I kind of like this one. I can send you guys this one as an example. Because we need to go through this circle theorem thing. I want you guys to understand. So please, guys, watch the circle theorem videos, and the next class will start right up where we left off. All right, guys. Cool. Maureen, Denise, Jay, please have a wonderful week. Please, God bless you guys. Just stay with me, guys. Just stay with me. We can do it in Jesus' name. See? So watch the videos, guys, and I'll talk to you guys individually on WhatsApp. I need to keep in touch with you guys. It's only 1 month till the exam, guys. Today is the 23rd, so it's only 1 exact month till the 23rd of June when the exam is. They're talking about extending the exam, guys. We don't know, but we're still just preparing like the exam is that day. Cool. They said they might extend the exam 3 weeks, but I don't know. So I'm not really taking a chance. We're doing everything we can until that day. Cool. So I'll see you guys Thursday.
Yes, sir.
And stay safe and God bless, guys. I'll see you guys soon.
Same to you, sir.
You're welcome.